Hey, back again, Mr. Dow here to talk about section 6.3, binomial and geometric distributions. Before I talk about the binomial setting, I have to at least give you a definition. The following four conditions must be met. One of two things can occur. When I'm shooting baskets, I can either make it or miss it. Let's just call this success or failure. I have a fixed number of observations. Maybe I'm going to shoot 10 baskets in a row. The n observations are independent, so shooting basket number 1 has no influence on whether I'm going to make or miss basket number 2. And the probability of success is the same for all observations. If I meet these four conditions, I am considered in the binomial setting. Here's an example. A family are going to have 3 children. I want to know the probability of all 3 having girls. First, I have to decide if I'm even in the binomial setting. Well, let's go through each of the checkpoints. Do I have success and failure? Yes, I do. Boy or girl. Do I have a set amount of observations? Yes, I do. 3 children. Are all observations independent of each other? Yes, they are. The gender of one child does not influence the gender of the next. And is the probability staying the same for each observation? Yes, I have a 50% chance of getting a boy or a girl. I now have a binomial random variable where x is the number of successes. I can then make a binomial distribution. And the notation here, b with a coordinate pair, first number will be the number of observations, the second number, the probability of success on any given trial. X would be all possible whole numbers from 0 through n. From the example up above, I would have b 3, 0.5. Let's talk about the binomial coefficient. How many ways can I achieve success among n observations is given by the following formula. N choose k is the proper terminology for the larger parentheses. Is given by the formula n factorial. If you recall what factorial is, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. N is the total number of observations off of k, how many ways can I have success? The example that I did, how many ways can I get 2 girls from 3 children? That would be 3 choose 2. That's 3 factorial over top of 2 factorial times 1 factorial. There are 3 ways to get 2 girls from 3 children. Boy, girl, girl. Girl, girl, boy. Girl, boy, girl. I can then turn that into a binomial probability. What's the probability of getting 2 girls and 3 children? I'm going to use the binomial formula. N choose k, binomial coefficient, times the probability of success raised to the k, times the probability of failure raised to the n minus k. And you can calculate all this out. 3 choose 2, 0.5 raised to the 2 times 0.5 raised to the 1. And you'll see that it is 0.375. Your calculator can also make this calculation for you. The calculator command is to use the binomial PDF setting. And then you're going to type in 3 numbers. N, the total number of observations, P, your probability, X, the number of ways to have success. This will calculate your binomial probability. You can find this under the command second distribution and then option 0. And let me take a second to show you how that would work. So on the calculator, I'm going to hit the second button, bars to activate the distribution list, and I'm going to scroll to binomial PDF, which happens to be option A on this particular calculator. I enter in 3 numbers, in this case 3 children, comma, probability of success, 0.5, and how many girls do I want? 2. Close the parentheses, hit enter, and I have a 37.5% chance of getting 2 girls out of 3 children. What if I wanted to know the probability of getting 2 or fewer girls out of 3 children? Well, that would be the binomial PDF of 2 girls, the binomial PDF of 1 girl out of 3 children, plus the binomial PDF of 0 girls. I would have to sum these 3 different probability distribution functions, or the calculator has a shortcut built into it. That would be second vars, option B, binomial CDF, which stands for cumulative distribution function, meaning to sum. The command is the same, 3, comma, probability of success, comma, 2 or less girls, or fewer. And this is going to be the summation of a binomial PDF of 2, plus a binomial PDF of 1, plus a binomial PDF of 0, giving me there's an 87.5% chance of getting 2 or fewer girls out of 3 children. In your textbook, on page 388, there's an example demonstrating this shortcut. If you're uncomfortable using the shortcut of a cumulative distribution, you can always do individual binomial PDFs and simply add them up. The cumulative just saves you a little bit of time and does it all in one step. Let's talk about simulating binomial experiments. On the calculator, math, over to PRB, option 7, random binomial values. The key command, there's going to be 3 numbers that go in. I'm going to select the number 1, comma, percent of the time for n trials. I'm going to simulate getting success or failure, where selecting the number 1 is considered a success. Here's an example. Let's say when Shaquille O'Neal was playing basketball, he was known as being a horrible free throw shooter. Let's say he shot 68% of his free throws. I'm going to let the numbers 0 represent he missed the shot, the number 1 represent he made the shot, and I want to take and look at his next 10 shots. Here's the calculator simulation. I select math, over to the far right to PRB, option 7. I would like to select the number 1, 0.68% of the time, or 68% of the time, and I'm going to look at the next 10 shots. The calculator is going to output a series of 1s and 0s that represent whether he made or missed, depending on my definitions. If I count the number of 1s, I'll see how many times he made a shot within those 10 shots. If I hit enter again, it'll give me a new series of 0s and 1s. I can then count the 0s and 1s to see how many times he made shots out of those 10 simulations. I can do this however many times I want. Rather than counting all the 1s, I can let the calculator do the summation for me. Here's the key sequence on that. Math, over to PRB, option 7, setting it up the same way as I did before, selecting the number 1, comma, 68% of the time, and selecting 10 numbers, closing the parentheses, I'm going to store that information into second L1 alpha colon, and I'm going to sum that is in second list down to over to math, option 5 for sum, into L1, close parentheses, and hit enter. And what the calculator has done has stored all my ones and zeros into list 1 and then added up all the ones for me. If that went too quick, you could watch this again, or here is the key sequence that I used. If you're interested, you can actually go to L1 and look at all of your ones and zeros. You can scroll down and you can count that there are indeed 8 ones out of the 10 numbers in the list. And here are some notes on everything that I just did. The final thing that I would like to mention is the mean and standard deviation if you're in the binomial setting. So these are the formulas for your mean and standard deviation of a binomial random variable. And that wraps it up for the binomial setting.